Hello everyone, myself Ankita Shinde from Sadhana Education English Medium School, Nasik Road, Nasik, grade 10th. A very warm welcome to Borade Maths Academy. At first, I would like to say specially thanks to Borade sir for giving me this wonderful opportunity. Thank you so much, sir. So, let's start. Science Part 1, 10th Lesson Space Mission. What we are going to learn in this chapter? We are going to learn in this chapter Space Mission. Classification of artificial satellites. Satellite launch vehicles. Artificial satellites. Orbits of artificial satellites. Space mission away from the Earth. So let's start. Man has always been curious about unknown places and he has always been eager to expand the horizons of his knowledge by exploring the unknown world. He must have had a deep curiosity about the space and many twinkling stars in the dark sky. He must have had been dreams to fly to the space and must have been working for that. So today's first topic is space mission. Substantially development in technology, especially space technology, in the latter half of 20th century resulted in the development of spacecrafts making space voyage possible. Since then, more than 1,000 artificial satellites have been placed into the orbit around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. So, we will learn about all this in this chapter. We can classify the space mission into the two categories. In one of them, space mission, the objective is to put artificial satellites in orbits around the Earth for research and various other useful applications. The objective of the second type of mission is to send the spacecraft to the outer space for close observation and understanding of the objects in our solar system or even outside the solar system. So, do you know? The first person to go into the space in a spacecraft was Yuri Gagarin of the USSR. USSR stands for Union of Soviet Socialistic Republics. He orbited the Earth in 1961. The first person to step on the moon 1969 was Neil Armstrong of USA. USA stands for United States of America. Rakesh Sharma of India obtained the Earth in 1984 in a Russian spacecraft. Kalpana Chawla and Sunita Williams of the Indian origin have also participated in the space exploration through mission organized by NASA. NASA stands for National Aeronautics and Space Administration of USA. USA stands for United States of America. So, can you recall which type of telescope are orbiting around the Earth? Why it is necessary to put them in space? So, please observe the picture. Need and importance of a space mission. The world has become a global village due to the space mission. Today, we can conduct a person in any part of the world within a second. We can gather information about worldwide events sitting at home. You all know that importance of internet. You know that, na? Due to the internet, every information is available at our fingertips. It has become possible get advice alert about natural calamities and take proper precautions. During the war, it is possible to get information about the action of the enemy through aerial surveillance using satellite. It is also possible to explore the fossil reserves and minerals in the Earth. Thus, there are unlimited applications of space mission. Today, space technology is an inventable part for development of a nation. The satellite have various other types of instruments depending on their functions. One such satellite is shown in figure. Please, can you observe this? signals transmitted from the Earth to the satellite and from the satellite to a mobile towers, and mobile phones are also shown. So today's next topic is natural satellite. A natural satellite is an astronomical object orbiting the Earth or any other planet. The moon is the only natural satellite of the Earth. Please remember this. Some other planets in the solar system have more than one natural satellite. Similarly, if a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called as an artificial satellite. If a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called an artificial satellite. Please note that this is the definition of artificial satellite. The first artificial satellite, Sputnik, was sent to space by Soviet Union in 1957. Today, more than thousands of satellites are orbiting the Earth. The satellites work on solar energy. So, solar photovoltaic panels are attached on both sides of the satellites, like a wings. Instruments are installed in the satellites to receive and transmit signals from and to the Earth. The satellites are sent into the space to perform various functions. Depending on their function, satellites are classified into the following categories. So, types of a satellite, function of the satellite, the names of an Indian satellite series and their launch vehicles. First, weather satellite. Function, study and prediction of weather. INSAT and GSAT. Launcher, GSLV. Communication satellite. Second, function, establish communication between different locations in the world through use of specific waves. Launch vehicles, INSAT and GSAT. Launcher, GSLV. Broadcast satellite. Third, telecasting of television programs. Function, name of launcher vehicle, INSAT and GSAT. Launcher, GSLV. Fourth, navigation satellite. Fix the location of any place on Earth's surface in of its very precise latitude and longitude. Launch vehicles, IR and SS. Launcher, PSLV. Military satellite. Function, collection information for secretary accepts. And the last, Earth observation satellite. Function, study of forest, desert, ocean, polar ice on the Earth's surface. Exploration and management of natural resources. Observation and guidance in case of natural calamities like flood and earthquake. Launcher vehicle, IRS. Launcher, PSLV. INSAT stands for Indian National Satellite. GSAT stands for Geosynchronous Satellite. IRNS stands for Indian Regional Navigation Satellite System. IRS stands for Indian Remote Sensing Satellite. GSLV stands for Geosynchronous Satellite Launch Vehicles. And PSLV stands for Polar Satellite Launch Vehicles. So today's third topic is orbits of artificial satellites. All artificial satellites do not revolve in a similar orbits around the Earth. The function of satellite decide the height of the satellite's orbit from the Earth's surface, the natural of the orbit circulation elliptical, and whether the orbit shall be parallel to the equator or making same angle within it. To put the satellite in its proper orbit at a specific height above the Earth's surface, the satellite is taken to the height using a satellite launcher. Then the satellite is given a specific velocity known as a critical velocity VC. In a tangential direction to the orbit. Please can you observe figure? The satellite then starts revolving around the Earth. The formula for the velocity means Vc can be derived as below. I requested to you all, please be careful while observing that picture. If a satellite of a mass m is revolving around the Earth in an orbit of height h with speed vc, then as seen in the chapter on gravitation, a centripetal force mv square upon r will act on it. Here, r is the orbitational radius of the satellite from the center of the Earth. So, this centripetal force is provided by the gravity of the Earth. Therefore, centripetal force is equal to means gravitational force between the Earth and the satellite. So here, mv squared upon radius plus height is equal to gmm upon r plus h square. Here, g stands for gravitational constants is equal to 6.67 into 10 raised to minus 11 Newton meter square kg square. M stands for mass of the Earth. Okay, 6 into 10 raised to 24 kg. R stands for radius of the Earth. 6.4 into 10 raised to 6 meter is equal to 6400 means 6400 kilometer. Small h stands for height of the satellite above Earth's surface, and r plus h stands for radius of the orbit of a satellite. So, mv square upon r plus h is equal to gmm upon r plus h square. So, vc square is equal to gm plus rh. So, velocity is equal to under root gm upon r plus h. Use the first equation. It can be seen that the critical velocity does not depend on the mass of the satellite. Please remember this. It can be seen that the critical velocity does not depends on the mass of the satellite. As the height of a satellite orbit from the Earth's surface increases, the critical velocity decreases depending on the height of the satellite orbit. How the above Earth's surface, the satellite orbit are classified. So let's learn. High Earth orbits. Height from the Earth's surface is greater than 357.80 km, means 35,780 km. If the height of a satellite orbit above the Earth's surface is greater or equal to 35,780 km, the orbit is called as high Earth orbit. The Earth's surface is greater than or equal to 35,780 km, the orbit is called high Earth orbit. As we will have in the next solved example, a satellite revolving in an orbit 35,780 km above the Earth's surface will take around 24 hours to complete one revolution. Please remember that. We know that the Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of revolution for the Earth around itself and that for the satellites to revolve around the Earth began the same. The satellite will appear to be stationary with respect to the Earth. For a passenger in a one vehicle, okay? This is example, okay? For a passenger in one vehicle, another vehicle moving parallel to the with equal velocity appears to stationary. This is what happened here also. The satellites are therefore called the geosynchronous satellite. Since the satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. Therefore, they are used in applications like meteorology and for carrying signals for telephone, television, radio, etc. So the second point is medium Earth orbit. Height above the Earth's surface is 2000 km to 35,780 km. If the weight of a satellite orbit above the Earth's surface is between 2000 km and 35,780 km, the orbit are called median Earth orbit. Okay, can you understand? The geostationary satellite orbit above the equator. Thus are therefore not useful in the study of polar regions. For this purpose, elliptical median Earth orbits passing over the polar region are used. Okay, those orbits are called polar orbits. Remember that in these orbits, the satellite complete one revolution in 2 to 24 hours. Some of the satellite revolves in a circular orbit at a height around 20,200 km above the Earth's surface. Global positioning satellite revolves in such orbit. So the third point is low Earth orbits. Height above the Earth's surface is 180 km to 2000 km. This is the third point. If the height of a satellite orbit above the Earth's surface is between 180 km and 2000 km, the orbit are called low Earth orbits. The satellite used for scientific experiments and atmospheric studies revolves in low Earth orbits. Depending on the height of their orbits, they complete one revolution in around 90 minutes. International Space Station and Hubble telescope also resolve in low Earth orbiting. Figure shows various orbits of satellites. Please observe carefully. So I think, do you know that a group of students from COEP, means COEP stands for College of Engineering Pune, made a small satellite and sent it to the space through ISRO. ISRO stands for Indian Space Research Organization. Okay, in 2016, the name of the satellite is Soyam and its height is around 1 kg. It is orbiting the Earth at a height of 515 km. The main objective of the satellite was to provide point-to-point messaging service using special method. So let's learn numerical solved example. Example 1. Suppose the orbit of a satellite is exactly 35,800 km above the Earth's surface. Determine the tangential velocity of the Earth's satellite. Given G for gravitation 6.67 into 10 raised to minus 11 Newton meter square kg square. Okay, M is equal to 6 into 10 raised to 24 kg for Earth. R 6,400 km for Earth is equal to 6.4 into 10 raised to 6 meter. H stands for height. Height of the satellite above the Earth's surface is equal to 35,718 km. So what do we should find? Velocity. Okay, V is equal to question mark. So R plus H is equal to 6,400 plus 35,780 is equal to 42,180 into 10 raised to minus 3 meter. Okay, R plus H is equal to 6,400 plus 35,780 is equal to how much? 42,180 into 10 raised to 3 meter. Okay, so velocity is equal to under root gm upon r plus h. Here gm is 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 upon 42,180 into 10 raised to 3 meter. Okay, so under root 40.02 into 10 raised to 13 upon 42,180 into 10 raised to 3. So under root 40.02 upon 42,180 into 10 raised to 10. So under root 0.0009487,909 into 10 raised to 10. So here under root 9,48,799.09. Okay, so 9487909. So velocity is equal to 380.245 meter per second is equal to 3.08 kilometer per second. Hope it will be understand for you. So the next numerical is example second. In the previous example, how much time is the satellite will take to complete one revolution around the earth? So given height of the satellite above the earth's surface is equal to 35,780 km. Velocity of the satellite 3.08 km per second square. So what's the solution? Solution is equal to, suppose the satellite takes t seconds to complete one revolution around the earth. The distance traveled during this revolution is equal to circumference of a circular orbit. If r is the radius of the orbit, the satellite will travel a distance 2 pi r during one revolution. Thus, the time required for one complete revolution can be obtained as follows. V is equal to, means velocity is equal to distance upon time is equal to circumference upon time is equal to 2 pi r upon t. Okay, t is equal to 2 pi r upon v is equal to 2 pi r plus h upon v. So put the value on the formula. 2 into 3.14 into 6,400 plus 35,780 upon 3.08 is equal to 86,003.38 seconds. So 23.89 hours, okay, is equal to 23 hours 15 minutes. Here, since the velocity is taken in the unit of kilometer square, the radius is also taken in unit of kilometer. Please remember that. So today's third topic is satellite launch vehicles. Satellite launch vehicles are used to place the satellite in their specific orbits. The functioning of the satellite launch vehicles is based on the Newton's third law of motion. Remember that the functioning of the satellite launch vehicles is based on the Newton's third law of motion. The launch of vehicles uses a specific type of fuel. The gas is produced due to the combustion of the fuel, expands due to its high temperature and expelled forcefully through the nozzles at rear sides of the launch vehicles. As a reaction of this, the thrust acts on the vehicles which drive the vehicles high into the space. The structure of the launch vehicles is decided by the weight of the satellite and the type of a satellite orbit. The fuel of the vehicle also depends on these factors. The fuel forms a major portion of the total weight of the launch vehicles. Thus, vehicles have to carry a large weight of the fuel with it. To overcome this problem, launch vehicles with more than one stage are used. Due to this, the weight of the vehicle can be reduced step by step after its launching. For example, consider a launch vehicles having two stages. For launching the vehicles, the fuel and the engine in the first stage are used. The importance of a specific velocity to the vehicle and take it to a certain height. Once the fuel is in the first stage is excited in the empty fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or on the unpopulated land. As the fuel in the first stage is exuded in the fuel in the second stage is injected. However, the vehicle now contains only one, that is the second stage. The weight now being reduced, the vehicles can move with higher speed. Almost all vehicles are made of either two or more stages. Okay, as an example, the structure of a polar satellite launch vehicles PSLV. PSLV stands for Polar Satellite Launch Vehicles. Development by ISRO. ISRO stands for Indian Space Research Organization of India is shown in figure. I request to you all, please observe the near picture. So, the launch vehicles are costly because they can be used only once. USA stands for United States of America has therefore development space shuttle in figure 10 which returns to the earth except for the fuel tank and can be received in multiple launches. Please always remember this. The rocket, a type of a firecracker used in Diwali, is also a sort of launcher. In this rocket, the fuel is ignited using a fuse and the rocket is projected into the sky just like a satellite launcher. Okay? Similarly, if a balloon is blown and released with its end or open the air in the balloon is forcefully injected and the balloon is pushed in opposition direction. This can be explained using the Newton's third law of motion. So, the fourth topic is space mission away from the earth. As we have seen above, artificial satellites are being used for making our life more and more enriched. However, in the previous standards, we have learnt about how the telescope abroad artificial satellites are used to gather information about various objects in the universe. Similarly, some space missions are used to gain future knowledge about the universe. In this mission, spacecrafts are sent to the nearby objects in the solar system to observe them more closely. New information has been obtained from such mission and it is helping us to understand the creation and evolution of our solar system. For such mission, the spacecrafts must have escaped the Earth's gravitational force to travel into outer space. Remember that the spacecraft must escape the Earth's gravitational force to travel into the outer space. To achieve this, the initial velocity of a moving object must be greater than the escape velocity of the Earth. Please remember that to achieve this, the initial velocity of a moving object must be greater than the escape velocity. Must be greater than the escape velocity of the Earth, as we have learnt in the chapter on gravity. Escape velocity on a planet can be obtained using following formula. Velocity is equal to under root 2gm upon r. G stands for gravitational constant is equal to 6.67 into 10 raised to minus 11 Newton meter square kg square. M stands for mass of a planet, 6 into 10 raised to 24 kg for Earth. R stands for radius of the planet, 6.4 into 10 raised to 6 meter for Earth. So velocity is equal to under root. So put the value on formula. 2 into 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 upon 6.4 into 10 raised to 6, we get 11.18 into 10 raised to 3 meter per second square. So what we get? We get 11.18 kilometer per second. So this is the spacecraft is to escape the Earth's gravitational force. To travel the outer space, it is must have minimum velocity of 11.2 kilometer per second. So I think, do you know the astronomical object closest to us, it is the moon. Light takes 4 seconds to reach from moon to the earth. It means that if we travel with the speed of light, it will be 1 second to reach the moon. However, since spacecraft travels at much smaller speed, it takes larger or longer time to reach the moon. The shortest time taken by spacecrafts to reach the moon so far is 8 hours and 36 minutes. So, moon mission. Since the moon is the closest astronomical object to us, the first space mission to object in the solar system were the mission to the moon. Such missions have so far been executed by USA, Soviet Union, European countries, China, Japan and India. The spacecrafts in the Luna series sent by Soviet Union reaches near the moon. Luna 2, launched in 1956, was the first such craft. After that, till 1975, 15 spacecrafts made chemical analysis of the moon and also measure its gravity, density and radiations. Last 4 crafts even landed on the moon and brought the sample of stones on the moon for analysis in the laboratories. All these missions were unmanned. America also excited moon mission from 1962 to 1972. The specialty of these missions was that some of these were manned mission. In July 1969, Neil Armstrong became the first woman to step on the moon. Remember that? July 1969, Neil Armstrong became the first human to stay on the moon. In 2008, Indian Space Research Organization ISRO specially launched Chandrayaan first and placed it into an orbit around the moon. It sent useful information to the Earth for about a year. The most important discovery made during the mission was the presence of water on the moon surface. India was the first country to discover this. Mars mission. Next of the moon, the astronomical object nearest to the Earth is the Mars. Many nations sent the spacecraft to the Mars. Mars mission is difficult and almost half the mission were unsuccessful. However, ISRO stands for Indian Space Research Organization, performs in this mission is remarkable and we all must be proud of it. The spacecraft Mangalyaan, made by ISRO, ISRO stands for Indian Space Research Organization. Using minimum expenses was launched in November 2013 and was pressed into the orbit around the Mars in September 2014. It obtained very useful information about the surface of the Mars and the atmosphere around it. So, Rakesh Sharma. Rakesh Sharma was the first Indian to travel the space. He went to space along with two Russian astronauts under the joint Indo-USSR space program. He stayed in space for 8 days. Second, Kalpana Chawla. Kalpana Chawla obtained her engineering in aeronautics degree from Punjab and in 1984 obtained her doctorate from University of Colorado. She was in space for 336 hours during research mission. While returning to Earth from space on 1st February 2003, the Columbia spacecraft exploded and Kalpana perished. Sunita Williams traveled to the International Space Station in Space Shuttle Discovery in 2006. She worked for 29 hours outside the space station. She created a record by staying for 192 days in the space. Remember that she created a record for staying for 192 days in the space. So next topic is mission to the other planets. Many missions have been executed by the study of other planets also. In some of these missions, the spacecrafts orbiting the planets, some lands on the planets and some just pass near the planet and observe them. Additionally, spacecrafts have been sent to observe asteroids and comets, and these space have successfully collected some dust and stones from the asteroids and brought them back on the Earth. We are getting very useful information from all these missions, clarifying our concepts about the origin and evolution of the solar system. So, our next topic is India and space technology. India also has made remarkable progress in the science and technology of launch vehicles. Various types of launch vehicles have been developed to put satellites having weight up to 2500 kg into all types of orbits. PSLV and GSLV are two important launches. The scientific and the technological feats achieved by India is in this field have significant contribution to the national and the social development of INSAT and GSAT satellites. Series is actively working in the field of telecommunication, television, broadcasting and meteorological services. Availability of television, telephone and internet services all over the nation has been possible due to the satellites only. EDUSAT EDUCAS satellite. In this series is used specially in the field of the education. IRS Satellite Services is working for monitoring and management of natural resources and disaster management. To exactly locate position of any places on the Earth's surface in the terms of its precise latitude and longitude, the IRNSS satellite service has been launched or established. So, information to the introduction to the very great scientist. Vikram Sarabhai is considered as the father of Indian space program. Vikram Sarabhai is considered as the father of Indian space program. Remember that. His effort led to foundation of Physical Research Laboratory PRL at Ahmedabad. In 1962, Indian government constituted Indian National Committee for Space Research under his chairmanship, and the first satellite launch Center was established at Thomba in 1963. The launching of the India's first satellite, Aryabhatta, into the space was the result of his effort. He played an important role in the establishment of Indian Space Research Organization, ISRO. So, our next topic and our last topic is space debris and its management. In additionally to the artificial satellite, some other objects are also revolving around the Earth. It includes non-functional satellite, parts of the launcher detached during launching, and debris generated due to the collision of satellite with other satellites or any other object in the space. According to this one estimation made in 2016, there are about 2 crores pieces of the length more than 1 centimeter revolving around the Earth. All this is nothing but the debris in space. Okay, this debris can be harmful to the artificial satellite. It can collide with this satellite or space crafts and damage it. This debris is increasing day by day. Soon, it will be difficult to launch new spacecraft. It is therefore very essential to manage the debris. Some studies and the experiments are being done with this in view. Hope that soon we will have a solution for this problem and the future satellite and spacecrafts will not be in a danger of any more. So friends, here we have completed our chapter. Hope it will be help to you. Thanks everyone for giving me your precious time. Thanks to specially Borade sir for giving me this wonderful opportunity. Thank you once more all of you. Jai Hind, Jai Maharashtra.